Okay, so as in the last video we have discussed about the defects of Niels Bohr atomic model. We have seen why his model got rejected, since he could not explain the Zeeman effect, Stark effect. He could not explain the poly-electron species. He just explained the mono-electron species, right? He could not explain the fine structure line as well. And in his theory, he said that electron revolves in an orbit. However, the one which we are going to study right now is the Broglie hypothesis. In that, we got to know that the electron can travel as a wave as well, right? And he discussed that Neil Bohr said that we can determine the position and the momentum of an electron at a time, but we cannot. According to Heisenberg uncertainty principle, we got to know that we cannot determine the position and the momentum of an electron at a time. So in today's video, we are going to discuss about the de Broglie hypothesis. Okay, so let me write here de Broglie hypothesis. Today we are going to study de Broglie hypothesis. Chapter 2, atomic structure. Alright. In his first point in the de Broglie hypothesis, he said that the matter can behave as a wave as well as particle, right? So what did he say in his first point was a matter has a dual nature. It can either behave as a wave or it can behave as a particle as well. So it has dual nature, right? Either particle or wave, right? So this electron, for example, I have in here, for example, I have an electron here. Now this electron can behave as a particle too, but it can behave as a wave as well. For example, like this. It will make an electron cloud, right? This is what it is, electron cloud. So it can behave as both, as wave, and it can behave as a particle as well. In his second point, he said that, in his second point, he said that wavelength is equal to, we know that wavelength is a property of wave. It is a property of wave, right? It is equal to h by p, where h is the Planck's constant and p is the momentum of an electron. Where h is Planck's constant whose value is equal to 6.62 into 10 to the power minus 34 joule second, right? Constant, and p is the momentum. momentum, which is equal to the product of mass and velocity, that we know too, right? It is basically the product of mass and velocity. The product of mass and velocity. In the third point, he said, in the third point, he said, from the above equation, as you can see, wavelength is directly proportional to the Planck's constant. Wavelength is directly proportional to the Planck's constant. Planck's constant. However, it is inversely proportional. But it is inversely proportional to the momentum of an electron, right? In the fourth point, we got to know that the de Broglie hypothesis is applicable on both microscopic as well as macroscopic matter. So in the fourth point, applicable for both microscopic as well as macroscopic matter. In the fifth point, we got to know that the de Broglie hypothesis equation is used to explain the wave properties of matter. The de Broglie hypothesis equation, which is equal to the wavelength is equal to Planck's constant divided by momentum of an electron, is used to determine or explain the properties of matter, wave properties of matter, right? So let me highlight this as well. So this was all about de Broglie hypothesis.